Hi, everyone. Welcome to Unfiltered Flow ELSC, the podcast dedicated to the progression of the fluid power and automation industries. I'm Megan Cook, co host Adam Burnett. Today, we're super stoked to have Mr. Peter Herder on. Peter is a full time lecturer at CalPoly in the Bioresource and Agricultural Engineering Department. Hi, Peter.
Good morning. Glad to be on the show.
Thanks for coming.
Super excited to have you. So, our first question always how you got into the business, first of all, and then you've had a very impressive career across education, sales, engineering, and manufacturing and fluid power. So, how did all of this unfold for you?
So it kind of unfolded all out of this. I guess I would say out of necessity. So when I graduated high school, I didn't really know what to do. So I did like aircraft. And so my parents said, you should probably look at Parks College, which was part of St. Louis University, and look at becoming an aircraft mechanic because you like working on things. So I went to Parks College, received my aeronautics degree as well as my airframe and power plant license. And during that program, of course, all aircraft depend on hydraulics for landing gear, all the control surfaces. So that's kind of where I picked up on hydraulics. I graduated from there in the early 90s at the time that the industry was not doing very well. And I needed a job. And I kept hearing that, if you want to go into engineering, you got to have AutoCAD experience. So I picked up the AutoCAD experience and then looking for a job after that. And in the parish that I grew up, Bob Gow, who owned John Henry Foster Company at the time, said they were looking for somebody to do hydraulic schematics. And I was like, well, I know a little bit about hydraulics from aircraft engineering, and then I know how to do schematics from AutoCAD. And one thing led to another. I was recreating all the hydraulic schematics from the outside salespeople that John Henry Foster um, had me doing. So I just kind of progressed on from there. At the time, Weatherhead was doing hoses and fittings. I went there. I went to Bosch. It was Racine at the time. So I went to Racine for Racine Hydraulics training there. Went to Milwaukee School of Engineering for more hydraulics training and just kind of kept picking up Schaeffer cylinders, Enertrols, IMI Norgren. And John Henry Foster really spent a lot of time training me in the industry, becoming more familiar with hydraulics. And I liked it. I just thought it was really cool stuff. That's kind of how I got into the industry. And then just kind of kept progressing from there. The red thread that goes through, I guess, my entire career, the single thread is all having to do with hydraulics. Working in the steel industry, still use hydraulics there. I was still the hydraulic expert every time something broke down and they said, oh, it's got hydraulic oil, call Pete. And kind of got into that. It's just kind of like one thing led to another. And now, we try to employ hydraulics as much as we can in our senior project designs. So our school is very much a learn by doing school, meaning that our senior design projects can be, we've built compost bedders that are speed that sense the ground speed and then distribute the compost accordingly. Biochar injectors, which inject biochar into the soil as an amendment, all kinds of, we're doing an agave harvester right now. And so some of these senior projects aren't in my area, but somehow I get roped into them, as well as the NFPA Fluid Power Vehicle Challenge. I
Great.
hope that's not too much, but it's kind of like, kind of out of necessity as I saw new opportunities either in fluid power and manufacturing where I could use that fluid power experience. I would just go from one company to the other, although I wasn't really like, I guess at one time that was almost like 25 years. I had 3 jobs in 25 years. And so averaging about 8 to 10 years a job, I thought that was a pretty good length of time to stay at companies. So
So,
I
what you're
hope you get
saying is it was the plan the entire time.
it is
Like
not.
everybody else that gets into this, Peter. We all set out to do it.
So,
I know. Wish I just and then the other thing is, I love solving problems. I think that's the key of engineering is to solve problems and to love solving problems.
You are just harvesting the agave, right? You're not doing any.
They will process it afterwards.
Okay, little side business there, huh?
Not for us, but for our sponsor. We might have to sample some of it, but
Of course, I like the way you define it, the red thread. I like that, the red thread.
yeah, I think I picked that up, through MBA school. They're always looking for the single defining
Yeah,
that strings through everything.
that's a good one. So, Peter, you're teaching future engineers at the university level, and sometimes, there's a disconnect between what goes on in academia and what actually goes on in the industry. So, what do you see as the biggest difference between what is being taught, what people learn in a program like this, and then what industry actually?
So I don't like Mohammed Sadek is another teacher there, and he really focuses on teaching the fluid power courses, which there are two in our department. My teaching in fluid power is incorporated in our senior design projects as well as some of our other systems that we do. The key thing that I think is missing is, and I'll fill in for Dr. Sadek too, but we talk about valves, we talk about cylinders, we talk about horsepower, we talk about the different varieties of pumps, but then actually the key thing I think that's missing is beginning with just with simple fluid connectors, hoses, fittings, port sizes. Some of the students that are working on the NFPA vehicle challenge, we were talking about a hydraulic motor, and I saw the motor, and he goes, "It has 3/4 inch ports on it," and I'm like, "There's no way that small of a displacement motor's got 3/4 inch ports on it." He goes, "No, look, here's the data sheet." And it was the thread diameter and pitch corresponding to that port versus a 1/2 inch port. And I was like, okay, we got to start somewhat at the basics here. A lot of it's just in that connection. And then the other thing is, even though we talk about all the components and, our lectures incorporate all those components, is understanding how to read data sheets, how to create a model code, and what necessarily makes sense when you're creating that model code. So those I think are the two biggest things that are missing. And I think what I often happens to me is I'll say if the student's got an issue like that, I like, "Oh, I'll just figure it out." And it's like, "No, I gotta back myself out of it. I've gotta teach them how to do it and walk them through the process of doing it, even though it takes more time." Because if I keep doing it myself, I haven't taught them anything.
Right. Yeah.
With the wide breadth of courses that you teach, Peter, regarding the material science to finance to project management, why do you think it's important for engineers to have that type of literacy?
Oh, when I start teaching like the finance and then the project management courses that we incorporate both for we have two different departments or two different degrees in our department. And one is ag systems managers, which are really focused on system management. The other one are the bioresource and agricultural engineers, which are a good combination between mechanical and civil engineers. I often start with the statement that money alone sets the world in motion. I think Sirius or somebody like that said that back in 200 BC, and it's so true. Money alone sets the world in motion. Then, at hydropower systems, they got a sign above their manufacturing facility that says nothing happens until something is sold. And it's so true. You have to be able to create an economic justification and a value for any engineering project that needs to be done. So, getting my MBA in addition to the engineering degrees I have, I think is really, it really created that you've got to justify why you're doing these engineering projects. I think one of the big disadvantages is, and I see in the industry, is that some people have an MBA, but they have no engineering experience. But they start looking at engineering decisions based solely on financial numbers and metrics, and it often leads to disaster. engineers with an MBA, I think, is far more valuable than just the MBA experience without having that technical background. And I think it was critical that I can explain from an engineering standpoint, try to translate that to people that have got the business degree but don't have the technical experience. And also my students, also the students too, when we start doing time value of money calculations and NPV calculations, and we do monthly budgets and we do mortgages, and students realize how interest rates truly affect the amount of interest that they pay on a 20 or 30-year loan or a car loan, or how fast that money goes, and how it's really important to if you mind the pennies, the dollars will follow, what Andrew Carnegie said. So
Talking about financial education there, we've also mentioned preparing students to be good leaders. How do you define good leadership in an engineering context? And can you actually teach leadership?
I think you can teach leadership. Leadership is taught by setting the example. But to complement that, there's a few books that I've read that I think are really good leadership books. The first one I got is a book called Marine Maxims. It's written by Lieutenant Colonel Tom Gordon, and it's a really, really good book about all the fundamentals of leadership and how to lead people. The other good leader, I think, is John Wooden, who taught UCLA basketball. He was probably one of the best leaders of the time. His statement that when everybody thinks it's the same, nobody thinks. And so leadership incorporates getting people from different opinions, different backgrounds, different ethnicities, and rolling that diversity into making good leadership decisions. Leadership is really about understanding who you're working for, the people that you're working for. That's the key thing. And those people, sometimes they're subordinates. um, we had a guy that came in a couple weeks ago, talked in the Ag Engineering Society, and he was from Bungie, North America. And one of the things that he brought up was they wanted to have this company lunch for all the hard work that everybody had done. So they were going to make tri-tip, which is a particular cut of beef, and then have a big tri-tip lunch for everybody. Well, he cooked the tri-tip the way he liked it. And then he realized it's not about me. It's not about cooking it the way I want it to taste. It's about how the people that are having the lunch want their tri-tip to be. So those are good examples of leadership. So leadership is you always got to be kind of learning from other people so that you can pass on those good habits, but also reading as well. So Maxwell, Simon Sinek, all these guys have really good leadership podcasts and books to be reading, as well as, John Wooden, Colonel Gordon, the really, really good books to be reading. So leadership is educating yourself so you can pass it on to the people that you're leading.
That's a great point to bring up. It's at the forefront right now, Peter. What employees value at this point isn't just a paycheck. There's a lot that you said there in a very short period of time that will hopefully resonate with leaders out there.
Hopefully, at the heart of all leadership is integrity.
So
And that includes being honest with yourself. That's the key.
it's a tough thing to do sometimes,
It
isn't it?
is. Yep. Absolutely. Absolutely. You don't want to admit there's some things you've done, but unless you can admit to yourself, then you'll never be able to get that integrity.
It's 100%. So, what is a lesson from your time in the industry that you bring to the classroom now that you wish someone would have taught you earlier in your career that you think is really good knowledge for these young engineers to have?
Dude, that we could go on for hours about that, all the mistakes I've made and then all the things I've learned. But I think the key thing is find good people that you want to work with and be patient and listen to what they have to say. When we're young, you want to go out of the gate and you want to change, change, change. And I've often said, it's really a marathon, not like a 5K or a 10K. A marathon, you start off, and if you start off running an 8-minute mile to begin with, and you think you can maintain that 8-minute mile for 26.2 miles, that's that's a challenge, so pace yourself even though you wanna go faster, uh, throttle back a little bit, listen, learn, observe. Observation, I think, is the key thing. Observe what some of the experienced people are doing and find good people that are genuinely out to help you.
As you create um, different programs for your students, you have to keep an eye on what industry trends are and what industry would like. How do you gather industry support for your current and next generation education?
So, I still work for hydropower systems and then work for them while teaching as well. So they keep me in touch with, projects that are going on throughout industry. So I still keep my foot in the door that way. NFPA, National Fluid Power Association, is another really good source. And then the other thing is, you got to open your mouth to get fed. If you want something and you see that an organization is doing something, open your mouth and say, "Hey, I think my students really would like to listen to this or hear about this. Um, can you come in and give us a talk about this?" And we found really good support from people, especially like what we call our Ag Engineering Society, which every first Wednesday of every month they have a guest speaker come in and they hold their meetings. And so in the fall of this year, we had people come in from the National Fluid Power Association industries, and they came in and talked to our students about what their companies do. So some stuff that I wasn't familiar with, some companies even in our own backyard that I wasn't familiar with, and they come in and talk. So that's a good thing.
And that's also a good way for the students to meet some of these business owners also and get involved to have some opportunities coming out of the gate as well. So that's really good.
Absolutely. Yep.
So hydraulic, electric, controls, all very different disciplines that have now, basically merged into one engineer at this stage of the game. So, how did you develop fluency across all of those? And how do you translate that in the classroom as well?
So I still think at the core, my fluency is in fluid power. It's what I've done for 30 plus years. That's where my fluency lies. When it comes to controls and programming, I think I've associated with enough people that have got enough experience in there that we can converse in the language, that language being, what type of program we need to do, what type of sensors we need to do, what type of control systems do we need that allows me to converse with them in a language that we can discuss the problem, understand the problem. But if you ask me to write a program in Codesys or any other programs out there, no, it's not going to happen. You start talking about, you know, CAN networks and J1939 and all these other things. I'm like, "Nope, nope, nope," but I know somebody that can do it.
That's the
Hey, that's
key.
the
Yeah,
important part. You know somebody that can
yeah,
take care of it for
yeah,
you.
yeah.
Yes, yes.
And before we started the recording, we're talking about some of the we're talking about your new computer and hassles like that. How busy you've been. So, how do you stay current with industry trends while you're also teaching, running a classroom, advising students, and everything else?
I think it's you just try to stay up with things, like your inbox is always being flooded with new information from somebody else. Couple things, the New York Times does a great job of showing what's going on with technology, Wall Street Journal, some of those trusted publications are good places to learn, as well as different trade journals, that show kind of the trends that are happening out there. So I try to stay ConExpo. ConExpo was a great place to
Mhm.
go, to see what industries are going on. Now, some of the stuff is, maybe 3 to 5 years ahead of things, but going to ConExpo, seeing those new prototypes that are coming out, I think that's the way, to stay ahead of what's going on with industry. And, AI is always challenging, it's always,
Right.
We incorporate it into our classrooms. Like we're doing a class right now on project management, and we talk about like creating a Gantt chart and a schedule and starts and finishes. And you wonder, like, okay, if I just turn this into AI, what's AI going to say about the Gantt chart that I created? Why not take advantage of it? Why not try to use that information? But you still have to be able to question that to the point where does this make sense? And the only way you're gonna find out if something makes sense is if you've done it before and like, that's not the answer I ended up with.
So you've worked across automotive, custom products, steel industry. How different are those worlds and what transfers between them all?
So what transfers between them all is kind of efficiency and quality. If you're making a custom or a bespoke system and you know, if you make a mistake on that one system, even though the profit margin can be really high, you've eaten away that profit. So quality control is critical on custom systems and being, and understanding what you're trying to manufacture. In the automotive industry, we were producing parts for Class 8 trucks as well as automotive transmissions, so 10-speed transmissions. And our goal was to get up to 7 million pieces a year for these transmission parts for Ford and GM trucks. And you figure, okay, 7 million pieces, the profit margin per piece was very, very small. But if you said if you sent 1,000,000 pieces out there that were bad, which you could easily produce quite rapidly, now you've got 1,000,000 bad pieces out in the field that are scattered all over the place. Again, going back to quality control and efficiency, you've got to stay on top of those things. So the single thread that goes through both, low volume highly engineered systems versus high volume, high production is keeping track of that quality and that efficiency of the operations.
The last question I asked you, I wanted to follow up on that. I asked you how you stay current while you're running a classroom, basically is what I asked you. Follow on to that would be, how do you decide what to stay current on?
That's
Not everything is relevant. So how do you decide what you want to invest your time in?
that's a really good question. But there's a lot of stuff I see that there's a lot of commonalities between systems, and you're talking about electronics. Well, you start talking about electronics and fluid power, there seems to be, you know, amperage versus pressure, voltage versus flow. There's some commonalities between that. I think there's commonalities, and I don't think you can go like if I tend to focus more on agriculture because that's what we do. There's a lot of commonalities between farm equipment and machinery um, that can be transferred, that knowledge can be transferred to other industries. So I don't think it's important that you know every little detail about every industry. I think it's stay focused kind of in the industry that you're in, and then look for commonalities between what you know and maybe an adjacent industry that's next to it.
That makes sense. That makes sense.
This is a follow-up to that follow-up,
Okay.
actually. So, the advice that you would give to a young engineer that wants to be more well-rounded or have a more well-rounded career rather than staying in a narrow.
So there's a book I'm reading, and they bring up the topic of a cross section of a population that they studied versus I want to say more longitudinally or more vertical in there. So the question is, do you want to be broad? Do you want to study a cross section of engineering and different industries, or do you want to go really deep into one industry? I think it's kind of going back to what we started with, it's that integrity, understanding who you are as a person and what you really like to do. There's a couple engineers that are working on their master's program that were my seniors last year, and they're focused on some very specific research, and they like to do that. Our department has we've got professors and doctors that have spent research in aquaculture, that have spent research in electronics and control systems and surveying. I think it's kind of a more of a personal choice what what you wanna do. I've always liked understanding a variety of topics and, get deep into one, but not so deep into it that that's what I spend the next 20 years doing. The advice I'd give is, look at yourself, look at what you like to do, were those classes do you like to do research, My son, graduated University of Oregon last June, and he got accepted into their PhD program. So he's going to focus on one specific aspect of social psychology, um, and he really enjoys that and going deep into that. For me, that's not what I like to do. So I think you just got to kind of find out, if you find something, and I come from a large family of 8 other brothers and sisters, and they always tell me when I find something, I go digging into it as deep as I can. But then it's like, then I'll find the next thing and go on to that there. So I go about 80% deep, and then I kind of stop and like, okay, I need to find something else to do. So, but I think it really comes to personal decision.
Out of curiosity, because this comes up all the time in what we do now, Peter, true engineer versus that sales engineer, right? So for a lot of the integrators that we work with in fluid power, they're looking for that mix, right? However, however that comes about.
Yeah.
So this might not be something that you can answer in pure numbers or anything like that, but I'm just curious how many of the folks that come out of your program are that pure engineer that stay in engineering and want to do that versus the ones that want to branch out and get into the sales engineering aspect of it.
I would say coming out of the program, 80 to 90% want to be pure engineers. Once they're out for a few years, I think that number drops. I think if, engineering's always known for its kind of introverted personality types. But I do think once they get out and start discovering the business side of it and the problems that they can solve, then they can turn into more of that salesperson. A while back, I was working with a company in Louisiana and a really good subsea company. And one of my customers came in and he goes, "What are you coming in today as, an engineer or a salesperson?" And he goes, "Because today I need an engineer. I don't need a salesperson." And I was like, "Okay, what's the problem?" So, if you can present both things to the customer, I think that's a good way to go. The hardest part about being a salesperson is saying no. No salesperson ever wants to say no,
That's
you
right.
know?
Yep.
Yeah.
Well, I've met a couple of engineers that never want to say no too. Oh yeah.
Yeah, that's true. We
Yeah.
know a lot of those, Alan, don't we?
Until you start getting deep into the problem and you're like, "Oh,"
Yeah. Or what it's going to cost. Yeah.
and that's like, like in the project management course, we were doing work breakdown structures and, the project always looks simple to begin with, but let's start driving it down. Let's start
That's
drilling
right.
down to the details. And it's like, "No, that doesn't look so attractive now."
Yeah. Yeah. Things can go sideways real quick and get expensive.
Absolutely. So, but I love teaching. I think, at this point in my career, there's some life to it. Because you can spend, it's hard being on the road. I mean, when you're on the road 3 weeks out of every month, sometimes that's really hard and really fatiguing. And then you've acquired all this knowledge after 30 plus years. What are you going to do with it? You got to pass that on. So, if I kept teaching for another 10 or 15 years, that's fine with me. And we've got a lot of teachers, not a lot, but I shouldn't have said a lot, but we've got some teachers that, you know, could have retired 10, 15 years ago, but they just love you gotta have something to do, and I think if you go to retire, you gotta have something to do. Otherwise, you're gonna spend a lot of money buying a lot of stuff on the internet that you may or may not need, and you're gonna go broke really fast.
That's how I got stuck with Alan. He retired and needed
You
something
bought
to
me
do,
on the
Peter.
internet?
So
But teaching is really rewarding, and, the question is, would you have started earlier? And it's like, no, I think I started right at the right point in my career, in my life.
well, it's so exciting right now in hydraulics, the fluid power industry as a whole. There's so much going on and so much out there and so many career paths that I think students, coming into college know nothing about really. And that's part of the reason that we do this is trying to get the word out of all we've all made a great career in hydraulics and sales and the fluid power industry. And I think the lack of knowledge there just blows my mind, right? That people don't know about this and how cool the people are and the products and how everything's progressing.
Absolutely. I think, and the fluid power is, you hear the statement that it is everywhere. It truly is everywhere. Even when I'm
It is.
talking with my students, on a different type of hydraulics, more hydrology, hydraulics, open channel flows, these concepts are still the same. But going back to fluid power itself, it's like, what do you want to do? If you go to work for like Blue River Technologies, who was acquired by John Deere, there's hydraulics in there. You go to work in any type of energy industry, from power plant generation to AI, there's fluid power there. Fluid power is everywhere, from cooling, from power gen to transportation to hybrid vehicle systems to agriculture to aircraft. It just is every aspect of our lives is somewhat touched by fluid power, You want your brakes to work on your car? Well, that's fluid power.
And your transmission.
And your
Yeah.
transmission too. Yep. Although I do have a manual transmission on one of my cars, actually 2 of my.
You don't have to worry about it getting stolen then. Yeah, that's one of the big things. Have a manual transmission. It's one of the biggest theft deterrents around right now.
Absolutely, yes.
Hey, I've got a really important question for you here before
Okay.
we wrap up. So, what advice would you give to someone going to Larry as to who the best tri-tip vendor?
In our area?
At the Tulare Ag Show.
At the
Who's the
Tulare
best?
Ag Show? Gosh,
Who's the
those
best tri-tip vendor at the Tulare Ag?
those I can't even I can walk to the place, and I know where it is, but I can't think of the name of it. I mean, it's like the one that everybody goes to.
If you draw us a map, we'll get it out there on our website. Huh?
I would tell you, though, and bragging about our school a little bit, our Agricultural Engineering Society, the AES meetings, before the meetings, so every first Wednesday of every month, they have their meeting, and they make tri-tip. Tri-tip and cheese it is, and their tri-tip is really, really good. Then the second best time with tri-tip is our school every year hosts the FFA state finals for the state of California in our region. So when the FFA comes to our school, they get volunteers and they get a large, I mean, I think 2,000 pounds of tri-tip, maybe a little bit more, and they cook the tri-tip for the FFA, and that's really, really good too. So and they cook it right behind one of our, shops, the ag shops
Oh,
between.
wow.
It's enough.
It smells good. I'm getting hungry. We got to wrap up. We got to wrap up. I got to get something to eat.
Yeah, so you can tell it's lunchtime here. We're on the East Coast. Alan's going directly to the food.
Yeah. Although last week some of our students competed, it wasn't 4-H, I think it was Latinos in Agricultural event in Dallas in Texas. They went to Dallas, and I said, "You gotta try the brisket, and let me know if you like brisket or tri-tip better."
Ooh, that's a tough one.
They liked the brisket better, but then they said there was one person that they one place they went to for brisket, and it was kinda tough. I'm like, "Yeah, you can cook tri-tip really well and turn out really good, or you can cook it bad," and the same thing with brisket, same way. No.
Red meat in general, I think, can be really good.
Although we do have a lot of good seafood out there too, so I try to, do both things.
Okay, one more question.
Okay.
If you could go back and tell your 20 something self one thing about building a career in fluid power and or any technical field for that matter, I guess we can open it up. What would that piece of advice be?
Oh, I guess the single piece of advice, this was like I said, this is another really tough question, but trying to narrow it down is, our school's philosophy is learn by doing. So my piece of advice would be some engineers get caught up in this analysis paralysis thing where they continue to analyze, 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 and they're so afraid to make a mistake or try something new. My career advice would be try it. See if it works. Understand what the consequences could be. And as long as those consequences are acceptable, try it. Learn by doing. That's the key thing because there's a lot of stuff that I've done that I thought would make sense and work, and it didn't. And the only way to find out is by doing it. So, key advice is learn by doing and learn from others too.
Find some good mentors out there. There are a lot of them running around that'd be happy to help. So that's
Absolutely, absolutely. And, there's a lot of good fluid power distributors out there. I think the ones that tend to be employee owned and, more family oriented businesses, I think they're the ones that are going to invest in their people more than some of the other larger organizations. And I'm not trying to be negative in any way, but it takes several years to develop a really good fluid power engineer, and you got to be patient.
This
Yep,
is
we've heard
true,
that.
and you hit the nail on the head, Peter. We're in a period right now where I think there's that opening for the true integrator distributors who are focused on finding the key people. They have the culture and the leadership in place to go forward there, and they are going to gain an immense amount of traction right now with everything that's going on with the consolidation and acquisition.
Absolutely, and they can lend a tremendous value out there. The Amazon way of selling fluid power is not the way to go. It is a technical product that can really change your business, if employed correctly, but it is not a product you just buy off the shelf and install it and be like, okay, it's good to go. It's a systems approach to
That's right.
solving a problem.
Peter, it was so great to have you on.
So here, thank you very much. I truly appreciate the opportunity to talk about this.
Yeah,
Thanks for agreeing.
absolutely. Hopefully, Alan and I can make it out to see you. I'd love to check out what you're doing out there.
Absolutely. Come by anytime. You can fly into our big two-gate airport of San Luis Obispo, or fly into Santa Barbara, fly into Fresno. You go to the Tulare Ag Show. We're about 2 hours away from there, so not far away at all. So please come by.
Very good. We'll take you up on
Okay.
that.
All right.
Definitely, definitely.
Thanks,
Thanks,
Peter.
Peter.
Really appreciate it.
Thank you all very much. Thank you again for having me. Bye-bye.